We're doing 4.2, adding, subtracting, multiplying polynomials. So simplifying polynomials by adding, subtracting, and multiplying. Okay, so the first thing I want you to do, I want you to start on exploration number 1. This is page 81 of your student journal. I want you to complete A through D with your groupies there. Okay? We're not going to spend tons of time, so do your best to focus up. Okay, ladies and gentlemen, I want to work through the first one just to make sure we're all on the right page here. When I square x plus 1, remember that means x plus 1 times x plus 1. So you've got to do what some people would call FOIL there. Okay, you get x squared plus 2x plus 1. And then from there, you're going to multiply the binomial by the trinomial. Notice they're using the terminology we went through this last section here. And so some of you are very good at going, well, I'm going to go this times this times that times that, and then that times that times that, and that times that. Some of you struggle a bit more with that, and I've seen some students, when they go a binomial times a trinomial, they use an area model. Where they use an area model and they say that's x, that's 1. So that would represent the x plus 1. And then up here you would have x squared, 2x, and 1. That's just a way to organize yourself. That gives you x cubed. That gives you 2x squared. That gives you x squared, 2x, and 1. The same thing you would get if you just did the distributive property. Okay, but anyway, you get x cubed. You get 3x squared, you get 3x, and positive 1. Okay, and then standard form, looks like it's already in standard form. If you would have done this, you would have maybe not have had it in standard form. You had to combine some like terms. But anyway, same thing. X cubed plus 3x squared plus 3x plus 1. And just for the sake of what we're doing today, I would like you to put a 1 out there to hold that coefficient's value. Okay? I know we usually don't show that. That will be helpful to you here in our next piece. Okay? So you get about 2 or 3 more minutes to work on the rest of those. I know you've started some of them. Get as far as you can. All right. Hey, let's check out this next one. It sounds like there's some pretty good discussion. Just so we know, when we square this, this becomes a squared plus 2ab. Okay, 2ab plus b squared. Okay, and then when we multiply this out, for those of you that are using this method here, it helps me to at least show what's happening, and then you can go either route. I honestly, when I'm doing this, I rarely use this area model method because it takes a little longer. But when you're learning it, it may be helpful to you. Okay, so when that's a times a squared is a cubed. A times 2ab is 2a to the second b. And a times b squared is ab squared. B times a squared is a squared b. B times 2ab is 2a, and now there's a b squared.
So it's kind of just like you smush everything together.
Kind of when you smush it together, yes. That's what we end up with. All right. So we got a cubed. These combine. That's 1a squared b, and 2a squared b's is 3a squared b's. And 2ab squareds and 1ab squared is 3ab squareds and a b cubed. And I am going to put those coefficients out there just because that's what we're going to be studying here in a minute, so that you guys can have a shortcut to do these. You like shortcuts. All right. Got 2 more. Give them a go. They're very similar to the ones you just... Okay, we're going to go ahead and put the next 2 up there. There we've got them. Next two. And once again, I am going to put the ones out in front. Please note that the only difference in between A and C is that with A, you had plus 3. Here, you have minus 3 plus 3. And then you have a plus 1 and a minus 1. Okay? I guess you didn't see that. So your signs have changed in the middle. And the same thing between B and D. Okay, your signs have changed. Plus 3a squared b, you have minus 3a squared b. Plus b cubed minus b cubed. Okay? Once again, I have those numbers out in front there. That's what you're going to focus in on now when you move on to exploration number 2. So I want you to take a look at exploration number 2 on the next page. This thing right here, that triangle, is called Pascal's triangle. Pascal's triangle works like this, just so you're aware. And we use it when we're multiplying out polynomials, okay, or binomials that are being raised to a power. So when I have a 1 here, and I have a 1 here and a 1 here, the way I get the middle term is to add 1 plus 1. That gives me 2. And then I have a 1 on the outside, and then a 1 on the outside, and then 1 plus 2 gives me 3. 2 plus 1 gives me 3, and then I have a 1 on the outside. I have a 1 on the outside, and then I have 3 plus 1 is 4, and 3 plus 3 is 6, and 1 plus 3 is 4, and a 1 on the outside. It goes on forever. Ones go down the side. Correctamundo. That is Pascal's triangle. Okay? Very cool stuff. Anyway, what I would like you to do is use your results for exploration 1 to find out, describe the pattern of the coefficients. Okay? And then using that information, answer questions B and C. Off you go. Hey, if I can have your attention back up here. Hey, please note the pattern that we're looking at here. If you take a look at row 3 of Pascal's triangle, actually it's row 4. Okay, the 1, 3, 3, 1. Those are your coefficients of each of these. You have a coefficient of 1, 3, 3, 1. Okay? We put our number out in front, 1, 3, 3, 1. Those numbers are our coefficients. 1, 3, 3, 1. 1, 3, 3, 1. Those are your coefficients. Now, we're not dealing with positive or negative, so it's the absolute value of that, right? So we have to think absolute in terms of absolute value of these numbers. Is the 4th row of Pascal's triangle. Okay? Yeah?
So, but that only works when there's no term in front of, like, the x, right?
Well, we'll find out. That's a good question. So I think you're saying, like, right here, if that was like a 2x. Yeah. So, for instance, if we did, say, like this problem right here. Okay? So, yeah, I mean, first, let's make sure we're clear. This is for a binomial that is being raised to the 3rd power. Sorry. Let's use a more general term here. So rather than like x plus 3, which would even make it more confusing, let's just say a plus b to the 3rd power. You can use that row to come up with your coefficients. This would be a plus b to the 2nd power. This row would be a plus b to the 1st power, which we know is just a plus b, right? 1a plus 1b. This one is a plus b to the 0 power. And what is anything to the 0?
1.
It's just 1. Okay? So this just gives you 1. This just gives you a plus b. This gives you a 1a squared, right? Plus 2ab plus b squared. Thank you. And this one gives you 1a squared, or 1a cubed, excuse me, plus 3a squared b plus 3ab squared plus 1b cubed. Okay, now here's the question that I have. There's a bunch of patterns that happen here. But how do I know, like, these other powers? What's happening with your power of a? Yeah, it's decreasing by how much? 1. Until you get to a to the 0, which is 1, so we don't show it. And what's happening to your power of b? Yeah, it starts at b to the 0 and it goes up. Or it decreases the opposite direction, if you want to think of it that way. Okay, so Walsh's question is a good one. We're going to actually get to that down here. Okay, but if I'm thinking of a plus b to the 4th power, I want you guys to write out what you think that's going to be right next to it. Use pencil, just in case you make a mistake. But use those patterns. If you make a mistake. Okay, now please note this. How many have it right so far? What else goes here? B to the what power? B to the 1st. Notice a to the 4th gives me a power of 4. 3 plus 1 gives me a power of 4. My powers, a good way to check yourself, my coefficient here is 6. It's a now to the 2nd, b to the 2nd, and 2 and 2 make 4. That's your check. Okay? Plus, now I'm at a coefficient of 4 again. 4, a to the 1st, b to the 3rd. 1 and 3 is 4. My last one is 1, b to the 4th. How many got it? That is quicker than multiplying it out by hand. Okay? So let's try some of these. Walsh, what you asked, I'm not going to actually show it right here. I'm going to show it down here. And you'll note that we start out with we don't have a's and b's here. We have numeric values. And we don't have 1s that make life easy like we did in Exploration 1. Okay? So if you think back to this pattern, if you think back to, this is a cube. So we go to, you'll hear it referred to as, well, it's cubed, so you got to go to the 4th row, which is 1 less than the power. I just think of it this way. I don't look at the first number. I look at the second number. That is your power. Okay? First power is here. Second power is here. Third power is here. Fourth power is here. Okay. You could, yeah. Swing it the other way. Okay, but I am going to look at the row with the 3 as my second term. So I get 1, 3, 3, 1. Okay, I know that that is a 1a cubed, 3a squared b, 3ab squared, and b cubed. So what I'm going to do is just right above this is going to be my guiding task here. And I have a cubed plus 3a squared b plus 3ab squared plus b cubed. All right. Now, what do the a's and b's mean when you have this? Well, this is position A, and this is position B. Okay, so in other words, A equals X, and B equals 2. You use substitution now. So right now, I want you to substitute the correct things in, the correct values in for A and B up there, into that. You can write it right here. Okay? Give it a go. Compare them with those neighbors there. Okay, that is what I got there. That's just the straight substitution, right? the A's got replaced with X, and the B's got replaced with 2. And now we simplify. This is just X cubed. This is 3 times 2, which is 6, X squared. This is 3 times 4, which is 12X. And this is 8. All right, questions? Ask your neighbor if they got it. If they didn't, make them tell you where they messed up.
Where I messed up. When I put the 2 in on the squaring, I accidentally squared the x's out.
All right. Okay, questions? Okay, now use your best reasoning skills. Paying attention back up here, notice the only difference between this one and this one is that you have a minus 2. So A is still X. B is now negative 2, and it's still a cube. How is that going to change your answer? Okay? Discuss it real quick. Okay, where does it affect us? Does it affect our first term? No. Does it affect the second term? Yes. That makes it negative 6x squared. Does it affect this term? It's a negative times a negative. Positive. Does it affect it? Nope, still 12x. Does it affect this one? Yes, what's it make? Minus 8. Tell your neighbor why it affected this term and this term, but not that term.
Because it's one number to the first power and the third power, so multiply negative by negative, which is positive, and then by another negative.
Okay,
Negative.
time is up. Why did it affect these two terms and not that term? Dallas?
Because the other two, negative 2 was the negative part was x divided, so it was squared.
Good. It was raised to the second power. This one was raised to the, this one was raised to the second. This was raised to the first, and this one was to the third. What if it was raised to the fifth? Would it change it?
Change the amount, but it's still negative.
Okay, if it was raised to the fourth, would it change?
Yes.
It would be positive then. So if a negative number is raised to an odd power, then what's the result? Come on, think through it, guys. Negative number raised to an odd power, what's our result? Okay? Negative number raised to an even power is? Positive. Okay?
You said even, and I just said even.
All right. How do you think you got it? Okay, try letter C. Let's make sure we're clear. You're using the same formula because you're raised to the same power. If the power changes, then you have to use a different row of Pascal's triangle. So if it was to the fourth power, then we'd have to go up here and use this one. Okay? If it was the second power, hopefully you just multiply it out in your head, but you could use that row of Pascal's triangle. Okay? But since it's to the third power, you're using that row. All right, here we go. There it is.
Oh, never mind. I didn't get it.
Okay, so here's the problem that ends up happening. You guys plug these things in. That's to the third power. And so this third power goes x cubed and 2 cubed. 2 cubed is 8, x cubed. I think this is supposed to be a third power right here. Thank you. Let's fix that.
Okay, now I got it.
All right. How many know where they made their mistake? How many didn't make a mistake?
Put my hand down.
Uh-oh. So how many don't know where they made their mistake? Okay, so are we comparing? Do you guys have it all copied out?
Yeah.
Okay, so you can't find where you made your mistake?
I just don't know why it's negative 36.
Oh, good question then. Hey, Jacob, can you answer that question? Why is it negative 36?
Why is it negative 36? Because it's...
Okay, no, so 2 to the second is 4. So right here with this little chunk, I like to think of each of these as their own individual pieces. 2 squared is 4. X squared times 3. And this is times negative 3. So there's our negative piece. Negative 3 times negative 3, or negative 3 times 3 is negative 9 times 4 is negative 36. Okay, and then this guy right here, this ends up becoming a positive 9 right there. So that's why that ends up being a positive 54. Okay? So making sure that you guys are bringing these pieces in. So that's 2 cubed and x cubed to give us 8x cubed. Okay. Any other questions? Okay, how many know where they made their mistake? Okay, very good. All right, I want you to take on page 84, there's a pretty good reference of Pascal's triangle and the expanded version all the way out to the 5th power. And you'll notice rather than calling it row 1 at the top, we call it row 0. Okay, so if we start at row 0, that kind of helps out. But like I said, I like to focus in on this part right here. That just tells me what power I'm dealing with. Since there's nothing here, that's a 0 power up there. Okay, your assignment. If you look at page 85 of your student journal, on page 85, you need to complete the extra practice on page 85.
So in other words, all of it.
All the extra practice. Now,
Okay.
please note, the first part should be easy. We haven't worked on any of that, but that's a quick review. You're just adding like terms. And please note, when you have a negative on the outside, what happens?
Add.
It's just minus.
Turns everything. It's like distributing a negative 1 in. Be careful. Flips all those signs. All right? If you want to use the area model to help with number 5, where you're doing a trinomial times trinomial, it's a good strategy where you actually list your trinomial to the side if you're struggling with it. And then you have your 9 different pieces you're going to come up with there. Okay. And then at the bottom you got some amazing binomial theorem stuff. Pascal's triangle. Woo!